Hello, Algebra 2 students. This appears like it will be our final set of notes for the year, unless I've overlooked something. And it's going to be our final set of notes, obviously going towards the next test, which will likely be next Wednesday or Thursday. And today we are talking about equations of hyperbolas. Please copy the title as well as the objective. The objective for today is to learn the specifics of equations of hyperbolas. Now I'll go ahead and apologize in advance. I anticipate that this will probably take a little longer to explain than some of the previous conic sections, but there is more to understand about the hyperbola than there was any of the others. So let's get started. Okay, the general equation for a hyperbola, which is to say its unit conic section formula, is this. We're going to have x in the second dimension. We're going to have y in the second dimension. We are going to have that equal 1. Okay, and that's important. It's got to be a 1 over there. And then we have a sign disagreement between the two second dimensional variables. So if one of them is positive, the other one must be negative. So for example, positive x squared minus y squared, or negative x squared plus y squared. They can be written in either order as long as one of them is positive and one of them is negative. Now, more specifically, when we look at the equation for a hyperbola, okay, we are going to see a little bit more information in there, and particularly we're going to be looking at equations that look like this. Of course, you have the sign disagreement between the two terms. One of them will be positive and one of them will be negative. We have the x minus h and the y minus k, just like we have for all of the conic sections throughout. And similar to the idea of the ellipse, we have the possibility of disagreeing denominators, okay, for our hyperbola. Okay, so you have x minus h, quantity squared, over a, minus y minus k, quantity squared, over b. And of course, they always equal 1. Okay, so several notes to go along with this formula. The positive variable in these between these two terms, the binomial on the left there, tells us which direction the hyperbola is going to open. Okay, so in this particular case, the way the equation is written, it is the x term that is positive, the y term is negative. Okay, so the positive variable, which is x, tells us which direction the hyperbola is going to open. Now, keep in mind, this is not a parabola that will simply go left or right. Okay, a hyperbola goes both directions. So when we answer which direction a hyperbola opens, we don't say left, we don't say right, we say horizontally, because it goes both left and right. Same thing vertically. We don't say up, we don't say down, we would say vertically, because it goes both directions. Now, your hyperbola has asymptotes inside of it. While a hyperbola looks similar to a parabola, it is not exactly the same thing. So it's not like two parabolas in a graph. Okay, hyperbolas are a different type of curve. So we're going to have two asymptotes in our graph, kind of constricting the hyperbola, making sure it stays in its proper places. And the asymptotes are going to be the result of, okay, a ratio where we have the square root of the b denominator, okay, in our numerator, and the square root of the a denominator in our denominator. And please notice I put the note on there, a belongs to x and b belongs to y. Now this ratio that you're looking at there, the square root of b over the square root of a, this is, believe it or not, this is slope. Okay, remember slope is, of course, the difference of the y values over the difference of the x values, or to put it back in junior high school terms, rise over run. Information about y goes in the numerator, information about x goes in the denominator. Well, look where we got the b from. It was information about y. And look where we got the a from. It was information about x. Okay, so it is rise over run, square root of b, over square root of a. Now also notice that that ratio carries a plus or minus in front of it. There are two asymptotes. They will follow the same slope values, only one of them will be positive and one of them will be negative. You'll see that more here in just a minute. Another piece of information, our major and minor axes, these are going to follow the same idea as we did with ellipses. If we take the denominator's values and square root them, then that is the distance from the center to the end of an axis. Okay, so if you double that, you get the overall length of the overall axis. Of course, the terms major and minor still apply, major being the longer of the two axes, minor being the shorter of the two axes. Our hyperbola is located at center at h comma k. That is the same as it has been through the entire discussion of conic sections. And another thing that has been similar throughout the entire discussion is that the negative values are built into the formula. Now, what you're getting ready to see is that there is a lot of information to consider as far as the graph of a hyperbola is concerned. Okay, one of the things you need to make sure that you keep straight is that the ideas of major and minor axes do not have anything to do with the direction that the parabola travels. They are completely independent from each other. The hyperbola might actually open in the direction of the minor axis, and vice versa. Okay, so let's take a look at some of the questions that are involved in order to get the basics of a hyperbola. Okay, here is an equation. This is a hyperbola. Both of our variables are in the second dimension. There is a sign disagreement between the two variables. One is positive and one is negative, so this is a hyperbola. X minus 1 quantity squared divided by 16 over y minus 7 quantity squared over 9 equals 1. Okay, we do not need to do anything to the setup of the problem. We don't have to do any crazy completing the square or anything like that. The constant on the right side of the problem over there is already a 1, so there's nothing really to worry about there. So we're free to begin answering the questions, and here they are. We're going to need to know where the center of the hyperbola is. Obviously, that's going to be important. We're going to need to know which direction the hyperbola opens, whether it's horizontal or vertical. Obviously, that's going to be important, or we will definitely misgraph our hyperbola. We're going to need to know which axis is major and which is minor, and we will need to know both of those lengths. And then we need to know the slopes of the asymptotes, because this is going to kind of be the final check and balance for graphing a hyperbola. Okay, and you'll see what I mean by that here in just a moment. Let's see if we can identify the values. Okay, how about the center of our hyperbola? Hopefully this is getting to be a no-brainer. Reading the x minus h and y minus k should be very clear to see that our center is located at 1, 7. Okay, now let's check the direction that the hyperbola opens. Remember that the hyperbola is going to follow the positive term, and it's going to open in that direction. Well, in this particular instance, it is our x term that is positive. That means our hyperbola is opening horizontally. Hyperbola is a two-sided graph, so we will have one side of our graph going to the left and the other side of the graph going to the right, but we simply say horizontally. Okay, now let's look at the equation and see if we can determine which axes are the major axis and the minor axis. Now this is the same as it was for an ellipse. We are simply looking at the size of the denominators. Clearly the denominator of the x term is larger. That is going to make the x-axis the major axis, and by default that makes the y-axis the minor axis. Now we need to know the lengths of these axes. Okay, just like we did with ellipses, we take the term in the denominator, we square root it, and then we double it. Okay, so on our major x-axis, okay, we have a 16. We take the square root of 16. That would be a 4. That means our axis travels 4 units in each direction away from the center, so its overall length is 8. And on our minor y-axis, the denominator is 9. We take the square root of 9, that is 3. So our axis travels 3 units in each direction away from the center, so our overall length is 6 units. Okay, now the asymptotes, the slope of the asymptotes is something that is kind of new to us, but remember, it is slope. So we want information about y in the numerator of slope. We want information about x in the denominator of slope. Okay, so again, we are looking at the denominators. Okay, the denominator of the y term is a 9. The square root of 9 is 3. That means our rise for our asymptotes is going to be 3 units. The denominator will come from the x. Okay, so the denominator under our x term is a 16. We're going to take the square root of 16, and that's going to give us a run value of 4. Our slope is rise 3, run 4, 3 over 4. And as we said on the original screen, okay, it is positive and negative. There are two asymptotes. One of them will come from a line that has a positive 3/4 slope, and one of them will come from a line that is a negative 3/4 slope. Okay, so let's take a look at another question, okay, because that's a lot of information to process. Let's see if we can get it right. Here we have a new equation, y squared over 81 minus x plus 11 quantity squared over 121, and that equals 1. Okay, well, we're going to have the same series of questions. We need to know where the center is. We need to know which direction it opens. We need to know which axis is major and which is minor, and we need to know both of those lengths. And it would be helpful to also know the slope of the asymptotes. Okay, so let's take a look one step at a time again. Our center, okay, this one lives at negative 11, 0. Okay, no biggie there. And how about the direction that it opens? Once again, our graph is going to open in the direction of the positive term. It is y that is positive this time. So our graph, oops, I have an error in my notes, should be opening vertically. Okay, hopefully that's the only error I have on this one. Let's take a look. Okay, our major axis and our minor axis, those come from the denominators. We can clearly see that the denominator of x is larger, so we should have a major axis on the x-axis. And of course, that means our minor axis is the y-axis. Our lengths, okay, our lengths are going to be the square root of the major x-axis. Square root of 121 is 11. Okay, and doubling it would be 22. And our minor axis length, square root of 81, would be 9. Doubling it is 18. Now, obviously, as I change the screen, this word keeps continuing to change. That's supposed to be vertically, not horizontally. Okay, and lastly, the slope of our asymptotes. Again, the square root of the y denominator over the square root of the x denominator. Okay, so the square root of our y denominator, square root of 81, is 9. And over the square root of our x denominator, square root of 121, is 11. Okay, so we have two asymptotes. One of them is sloping up 9 over 11. The other one is sloping down 9 over 11. Okay, now let's see if we can translate this information into a graph. Okay, here comes the challenge. I'm going to go through this information fairly quickly now, since that you know how to come up with these numbers. Our center should be located at 0, 2. The direction it opens follows the positive axis, so it's going to open horizontally. Okay, our major axis is going to be the y-axis, and that will be 6 units in length. Okay, so from our center point, we can go up 3, down 3. We can place points, and there's our major axis of 6 units long. That's going to force our minor axis to be the x-axis, and its length will be 4 units. So from the center point of our graph, we can go left 2, right 2, and we can put points there. Okay, at this point in time, you should have a little cross kind of developing inside of your graph. Okay, now here's where the rest of the information kind of comes into play, so I'll slow down a little bit here. Our asymptote slopes are found the same way, the square root of the y denominator over the square root of the x denominator. That's going to put our slopes at 3 over 2. Okay, now these lines slope through the center point of your graph. So in this case, we're going to have two lines both sloping through 0, 2. Let's look at the positive side of this first. From the center point, if we slope up 3 over 2, okay, what I'm going to do is I'm going to put two additional points, one from the left side of our center and one to the right side of our center. And if we have done everything correctly and we haven't goofed anything up, these points ought to be directly north, south, east, and west of the points that we already have in the graph. Then we're going to repeat the process, this time for the negative 3/2 slope. So negative 3/2 is going to go down 3 over 2. Okay, so I'm going to put 1 point to the left of my center point and 1 point to the right of my center point using the negative 3/2 slope. And again, if we have done everything correctly and haven't made any silly mistakes, you should have points that are directly north, south, east, and west of the points that already exist in the graph. Okay, so this actually, while there's a lot of things to consider, it kind of double checks itself, because at this point, what you ought to be looking at is a 3 by 3 grid where all of the points are directly north, south, east, and west away from each other. Now, having said that, please do not get in a habit of just finding a couple of these points and then just dropping all the other ones in so that they match up north, south, east, and west, because it's kind of a cross-check method. If you have messed up one step and then you base all your other ones on that one step, then you're going to end up with a completely incorrect graph, where if you had gone through the steps correctly, looked at all the values, one of those steps would have shown you that a different step was incorrect. Anyway, once you get to this point, okay, what we're going to do is we are going to install the box. Okay, basically connecting the 8 perimeter points traveling around the outside of your center. This is kind of like a no-fly zone for your hyperbola. Nothing about the hyperbola is going to intrude inside of this space. Okay. Now, another thing that we are going to do is we are going to install the asymptotes into the graph. Now, the asymptotes actually travel across the diagonals of your box that you have built here. They're going to go through the corner points of the box and through the center point of the box and then come out the other corner point. Okay, you're going to actually install these lines into your graph because they are going to provide the structure for your hyperbola. Okay, so you've got your points in your graph, you got your box in your graph, you've got your asymptotes in your graph. The only thing else that we need is the graph. Okay, and it opens horizontally. Okay, so we're going to be going sideways. Well, please notice the 2 points on the box that are to the left and the right of your center point. Those guys are actually going to be on your graph. So if we just kind of doodle in a nice curve that travels along these asymptotes and intersects those points to the left and to the right, we have a graph that looks like these 2 blue curves that were just added to the screen. That is the basic graph of your hyperbola. Each leg of the hyperbola approaches its asymptote as it races off to infinity, and it passes through the point on the edge of your no-fly zone. Okay, now that's a lot of information to consider, so I have another example that I'm going to go through. Okay, step at a time, just like we did this one. Okay, this time we're looking at y plus 1 quantity squared over 4 minus x minus 1 quantity squared over 16. And of course that equals 1. Remember, if these equations do not actually equal 1, then you will have to divide your entire equation by that value, or you could multiply by the reciprocal, whichever way you choose to think about it. Okay, but it's already equal 1, so we can go straight to our questions. Okay, the center of our graph lives at 1, negative 1. The opening direction of the graph, again, always follows the positive term, which is the y. So this time our graph is traveling vertically. Our major axis, very obviously, is the x-axis. Its length will be 8. Means our y-axis, our minor axis is our y-axis. Okay, there's our 2 points at the end of the major axis, 8 units apart. Okay, our minor axis is our y-axis. Its length is 4 units. So in the y direction, 2 units up, 2 units down, there's 4 units. And just for good measure, let's make sure that our box is actually shaping up correctly by getting the asymptote slopes. So we want the square root of the y denominator, which will be a 2, over the square root of the x denominator, which will be a 4. Now I'm not going to reduce this fraction down to 1/2, and you'll see why here in just one moment. Okay, so using these slopes, first one I'm going to put in is the positive slope. So I'm going to go up to over 4, going right through the center point of our graph. And there's why I didn't reduce it, okay, because it stepped very nicely on the north, south, east, and west of the points that we already have in the graph. Now I'm going to do the same coming across the negative slope down to over 4. And it looks like everything is graphing correctly because we are building a nice, neat box. So there's the no-fly zone. Our hyperbola will not enter this space. Okay, and if we connect our corner points going through the center, we end up with our asymptotes. Okay, now all we need to know is which direction the hyperbola is going, so we know which of the 4 remaining points on our box our hyperbola is going to make contact with. And in this case, our hyperbola opens vertically, so we will be making contact with the point above the center and the point below the center. And once again, we will doodle it in, basically so that the legs of our hyperbola are approaching our asymptote, and we will make contact with that point at the edge of the box, and that is a basic structure of your hyperbola. Well, I appreciate you taking time to get your notes taken care of. I apologize that they ran long, but of course the hyperbola, as you can see, takes a little bit more information to explain and understand. Anyway, I will see you in class.